Hi there, welcome to my VSCode extension. Recently I've been working with an organization called Algor, and I've been participating in hackathons and events, and I felt there's a need for an assistant for this particular case. So I thought when I was given this task, why not to make it specific to our organization and make it through an SLM. So I chose the Algor and contract generator. Now what does this do? It will give a generator smart contract based on the given prompt, and you have to select language, contract type, purpose, which then will be converted into a prompt string and passed to the model. Now let us let it be as it is. These are the available options, and now let me give a prompt like generate a code for clear program. Okay, now basically what it does, it will automatically add the purpose language contract type, and now when I click on generate, it will pass as a prompt to the model, and after a few seconds it will generate the smart contract in Python language. It may take a few seconds. So now we have the output. This is the smart contract output, and now if we want, we can simply copy it. And now there, after this generating the code, now the option to retry has been activated. Now we feel the option is or the code is not correct, we can click on retry option. It will pass this output and the other prompts to the model and ask it to retry it. Now the code seems fine, so we don't click on retry. Now if we click on deploy, then it will locally run a code in the PyShell with this logic, and deploy this on the blockchain, and it will return the app ID in exchange there. So it has written the address of the smart contract. Now let me give you a brief overview of the code. Okay, let me give you a walkthrough of my code. But before that, let me tell you how we collect data for our model. So now we needed code, and the best place for code is of course GitHub. So we just used GitHub. Just a second. We simply used a GitHub token, and we passed a few queries basically related to data we want, like Python language, Pylgor, and NFT minting, etc. And we just web scraped it, and now the problem was that after web scraping, the file, like, it was quite random. It was not as we can pass directly to the model. At first what we were doing, we were collecting a particular object and passing to LLM and converting to the required form, but even that didn't work, because like first of all, manual it wasn't possible, and every time there wasn't a single prompt generated by ChatGPT. Basically what currently we are thinking, we would be using LLM. We would be connecting LLM and passing the data and converting to the required form to LLM and passing it to SLM. Okay, so this is what we are saying, that like we have scrapped the data, and now this is not in the right form which we can send it to SLM. Like SLM needs very form, like any model, it requires input output format, and like from web scraping we got the output, but it didn't, from the GitHub we didn't get what input it would be. So we are thinking currently, we're just starting on this phase. We were using LLM, which we can use to convert it to required form, and then we can pass it to the SLM. Okay, now let me move you through the my code. Okay, so now this is my webview.ts. Basically nothing but the raw HTML and vanilla JavaScript, nothing much over here. Like we have the three buttons here: generate, retry, four buttons actually, copy also. Now this is a JavaScript, again a typical JavaScript code with event listener for every events, like for retry button, for deploy button, for clicking copy button, and all. Okay, now let me move to the main stuff. The backend file. Now, basically, what we did here, we already had we made a file inference.py and deployed to py for testing the individual logic. So what we did, we called the Python shell in the backend, and whenever we are generating the code, we are actually running this inference.py through a Python shell in HTML extension.ts and passing it to post message to the front end. Okay, like here's the generation code, generation part. We are simply running. Okay, my bad, just a minute. Yeah, we are simply running this particular part for inference, and deploy we are running this part. And now when it's come to retry, basically what we are doing, we are type of generating the same, we are using same logic of generate function, except that the fact that we are passing the context, that is the old code, and we are asking it to retry it. Okay, and so here is the inference.py, which is mainly used for generation or retrying. And these are the models we have, these are the model parameters we have been using. And as you can see, we have set a temperature a little high, because at first the answers were quite a few, like a few words were only given as the output. Still the answer, maybe due to high randomness or something, the answers are very vague, though the answer seems to be in a proper format now, but it is very vague and mostly inaccurate. We would be working on that, as mentioned, by collecting more data and processing it to LLM. Okay, and this is our deploy logic. We of course need these parameters to deploy it on the blockchain. And of course, currently have provided my own data environment file, but like when on the production scale, it would we would be collecting it from the users at the first time. Okay, so basically the simple deploy logics here. Okay, so I guess that's all from my side. Okay, let me show you my model. Okay, yeah, so I've used a free model from the Hugging Face called Salesforce Code T5 Small. The main reason to use it was because of global, like small scale resources, nothing special. And okay, again a very simple one. We passed it the data. The data was very small in number, and maybe that's the reason the model is not performing well. We are of course working on it. I guess that was all. Thank you.